So hello everybody, thank you for coming. This session was titled A Vision for 2020, Developing an API, Developing Applications in 2020. I don't remember exactly what was on the program. What I wanted to talk to you about here, and what I put in my abstract, is how to develop for IoT, how to develop IoT in a couple of years' time. And the reason I chose 2020 is because we're right now in 2016. There are so many APIs, so many things different that we don't know for sure how it's going to be. It's very difficult to talk about developing even 2017 because it's going to be, still a lot of complex things. So this is a vision. This is something that may or may not come true. It is something I've been working on with different teams inside Intel. We've been looking into how to develop, what is going to be needed to develop. We've been doing a lot of research into this subject, and I'm hoping that what I'm proposing will come true, but it may not. So one of your takeaways from this session might be everything I say here is completely untrue. The other thing I talked about in the abstract was who is going to be a developer for IoT. So in the keynote this morning, the gentleman from Qualcomm was showing where the developers are coming from. And the same thing from the executive director from OCF was showing we have 9 million web developers, 8 million mobile developers, but only 600,000 embedded developers. So who is going to be a developer for IoT? And again, I have to tell you, I'm not sure. Maybe all of them might be. If I get what I want, if I get my vision right, they all could be developing for IoT, which may be a scary thing, but let's leave that aside for a moment. But again, we don't know. So we commissioned a couple of researchers. We commissioned market researchers to figure this out, and we're trying to get a feel for it. Unfortunately, I don't have much on the who. This is something that we can work together. I'm hoping that by creating the how, by creating the API, by creating the way that people could develop, we can find the who. Maybe we should have done the other way around. Maybe we should actually have gone and figure out who are we going to target, because then would give us the APIs. Maybe I'm going upside down, but what we've known more or less is what and how, what kinds of APIs we're going to need. So let's start with myself. This projector is very blue. So starting with myself, am I an IoT developer? Who knows? Who knows what IoT is? So this is me. I'm a software engineer. I'm working as a software architect at Intel. It's been almost 5 years now that I've joined Intel. I've done a couple of other projects before. I've been involved with networking and involved with Linux and open source since the early 2000s, actually since 2000. And I've been involved with IoT for the past almost 2 years now, trying to figure out what we're going to do, how we're going to do it. And I helped found the OIC, the Open Connectivity Consortium, which is now the Open Connectivity Foundation. Helped start a couple of projects as well. So am I an IoT developer? I don't know. I mean, first we have to define what IoT is. I would like to think so. But let's start with this. How many of you here are actually tinkers, makers, like the question that Dirk asked Linus this morning? Do you make devices? Do you get boards and try to make interesting things of them? Anybody here? Yeah, we have a couple of makers, which is good because we have the Embedded Linux conference next door. How many of you, let's take the other side of the spectrum. How many of you program with JavaScript mostly? See, we have 3, 4 people. I know Zoltan does. We've been working on creating that JavaScript API. How many of you develop an operating system Linux kernel, device drivers. See, we have all of you different people. We have about 6 people of you. We have all of these here, and I would say all of you are in one way or another an IoT developer. But that's because we actually don't know exactly what IoT is. So let's start with that. What is IoT? What is IoT? And let's start with what IoT is today. Today, the Internet of Things is basically these 2 things here. Let me just tell you, the presentation will be online after the event, so you don't have to take pictures. You're welcome to. I'm not very photogenic, but you're welcome to. It's going to be recorded as well, so you can always come back and see it. By the way, I'm open to questions. You can interrupt me at any time and just ask for clarification. So what is the Internet of Things today? It's usually these 2 things I'm showing here, which is I called a cloud orchestration and a phone orchestration. So let's start with the one here next to me, the phone orchestration, which is the typical case of a wearable today. It means I've got my phone, which is controlling or is receiving from a thing via some kind of, actually I got the symbols reversed here. So it's using Bluetooth to talk to the thing, or Bluetooth LE to talk to the thing, usually your smartwatch or fitness bracelet. And then it sends that information to the cloud. And you may access later the cloud to get that information and do some processing for you, and hopefully you're getting some value of the data getting to the cloud. But without the phone in the middle, that thing does nothing, right? It doesn't have internet connectivity by its own. So without the phone in the middle, it's maybe recording data. And since these things usually are memory constrained, it might not record for a long time. The other case is one that happened to me. So I was replacing the air conditioning in my condo, and I decided to go for one of those smart air conditioning units. You must have heard of Nest, of course, and you must have heard of Honeywell solution. Turns out that those don't work for mini-splits. So if you don't have a furnace, those things don't exist. I started searching for it and found a solution for mine. And what happens is that the thing, there's a controller that you add to your mini-split, connects directly to the cloud. So it goes onto your Wi-Fi and starts talking to the cloud. I don't know where that cloud is. How long is it going to be available? What happens if my provider goes away? They decide, oh, I'm not going to support this anymore. I'm done with this service. It's costing me too much money. I might be left out of the service. And how can I get it, can get information from it? It's through the cloud again. So I'm in the same network. My computer, my phone are on the same network, but they cannot talk to that device unless they go through the cloud. So when I get home, for example, and let's assume I didn't turn the air conditioning on before to cool or to heat. I'm there sitting at home and decide, actually, I want to turn it on. I have 2 options. I can pick up the remote control, or I can do the web application. If I do it via the web, I can go and tell it turn on. I'll look at the unit, and I can count 30 seconds before it actually works and does anything. Sometimes it's 5, sometimes it's 30. I mean, what kind of IoT is this? So what kind of it is? We have right now an IoT which is isolated islands of things. We don't have an IoT today. That doesn't exist. Right? So this is very limiting. I told you, I mean, you see I'm a little frustrated with the device I bought. And this is why I'm not saying aloud which brand it is. But here's the thing. We need to fix that first, right? We need to make sure that devices talk to devices. Don't get me wrong, cloud is important. Without the cloud, we're not going to get the most out of IoT. So I do want to be driving home, and my phone somehow lets the cloud know I'm approaching home, and then the air conditioning turns on. I don't want to have to remember to do it. This happened to me several times, that I get home, it's cold because I forgot to turn it on the way home. I could turn it on from the office, but then it's too long. So the thing should be smarter than that. I would love to, I'm listening to music at home or in the car, and then it just jumps through. When I get home, it continues playing my playlist wherever I stopped. So all of these things usually require the cloud. And they do that usually because I'm not proximal. I'm not close enough to my network to do it directly. So don't get me wrong, cloud is important. And moreover, IoT is going to drive cloud business. There's going to be an explosion of cloud, more than it is today. The big data is going to continue to exist because we're going to be generating a lot of data. But here's the thing. We're leaving a lot on the table. So IoT needs to change first. IoT needs to go from isolated islands of things to really an internet of things. These things need to mesh. We might also say an intranet of things. And very often we're going to talk about extranet of things. Whatever you want to call intranet and extranets, that's fine. They probably apply to. So one of the principles we're going to have of the Internet of Things is local first. We need the local orchestration. I need my local devices to be controlling the network. I don't want to wait even 5 seconds for my air conditioning unit to turn on. Imagine turning on a light bulb, a smart light bulb, and even if it takes a second, just think about it. I was talking to a couple of friends this morning. The smart thing needs to be at least as capable as the dumb thing. Right? Sounds obvious. I mean, you're laughing, but yes, this is what we're seeing today. The other thing is, maybe some of the companies that do more cloud are going to disagree with me, but I'm going to say we need the data to be local first. So this is again the example here of the local orchestration. My data stays local. I will give my data to a cloud provider or service provider if I get something in exchange for it. I need an added value to give my data. It needs to be my option. This solves a bunch of problems with privacy and security. So let's avoid going to the cloud first. Again, cloud is important, but let's get the data first. And we're going to need the thing-to-thing communication. We can't have just mediated by a middleman. That's required, but we need the thing-to-thing communication. I need, my robotic vacuum cleaner to talk to the light bulb and figure out, the lights are off. That's probably because I'm not in this room. I might as well clean it. Right? I don't need to go elsewhere. And you can see here that sometimes they're disconnected from one another in that example here. That's because the networks need to be also self-healing. I'm going to need to have deployed clouds, private clouds, so on and so forth. So if we're talking about what I want IoT to be, I want IoT to be for small, medium, and big devices. We need that local orchestration I talked about, cloud for extra services, right, added value. We need to avoid lock-in, right, because, like I said, what happens if my service provider somehow goes away because it's been 2 years and they don't see the value, or they don't see the profit in this service anymore? Am I going to be left out of the device that I bought? So I can't have that lock-in. I need to have access to the protocol so that I can choose a different provider if necessary. We can't have an walled garden of these things. That actually gets me to another point, which was the network, the radio technologies that the devices talk to each other. I'm not sure there will be a consolidation of this or not. Everybody's using Wi-Fi today, but Wi-Fi is extremely expensive in terms of power for small devices. Of course, the Wi-Fi Alliance has come up with a solution for it, but so have a Bluetooth SIG, so have IETF with 6LoWPAN. So there are a couple of different technologies. I'm hoping to find at least one or two at most. Sorry, at most one or two. More than that, we start having difficulty with communicating. So I buy, let's take that example here. I bought a device that doesn't talk to the other one, so it's isolated in its own. That's no good. So what are the challenges to get that? We need to make something that is easy to use. The API, the code, so now I'm finally talking about code. Code needs to be easy to use. We need to be able to download it, and within 10 minutes I downloaded the SDK. I need to be able to do a hello world kind of IoT application, which probably will be blinking my lights. Right, so blinking lights in my room might be my hello world for that. It needs to be free, of course. No, not even talking about open source. But yes, it has to be free and open source. We're all in this Open IoT Summit together, we agree on that. But that's also because we need to avoid the lock-in that I just talked about. It needs to be well integrated. We have to have IDEs, we have to have the tooling for it, documentation, examples, samples.
Why does it have to be free? Open source doesn't have to be, you look at the code. Open source usually have open interfaces that can talk to each other.
Okay. Okay, fair question. Why does it have to be free, or why can't we just have open standards and have extensions? By the way, that was one of my topics furthermore. Yes, you need to be able to extend for commercial solutions. You need to have a service on top of this. If people aren't making money on somehow this is never going to launch. My point is, the entry point, which was the ease of use where I'm here right now, needs to be free. I need to be able to start with it. I need to get people the tools to get started. So when I asked who of you were makers, if you don't have access to it, you're not going to make anything. It all starts with people who are tinkering and are slowly learning what to do and how to do and come up with ideas, crazy ideas, which may or may not become a product. Right? I'm passionate about open source. I think that you have to have these tools as open source. But on the other hand, you're right. We need to have a path for commercialization. We need to have these companies be able to come in and provide an extra service. I'll get to that more at the end of the presentation. It needs to be flexible, the choice of hardware. It needs to be scalable. When I'm talking about the tiniest devices to bigger ones, I need to be able to figure out where I'm going to go. Let's not forget security, right? Security is going to be very, very important. What Linus told us this morning is security is useless before functionality, and that is true. In the IoT world, I'm going to say the opposite is also true, which is functionality is useless unless you also have security. So we're going to have both, right? And we can't detect people, they're going to have to download this new SDK. It has to be with familiar tooling, familiar environments. So, programming them, yes?
I'll comment also on the statement here because I really didn't agree with Linus this morning. Because when you build security, you have to build it from day one.
So,
a lot of the issues right now with the system, and if you didn't think about security, how I can security, definitely will have a lot of holes because the system wasn't built.
Agreed. So I'm just repeating what you said. You said you disagreed with Linus this morning, saying that you have to build it from day one on security, and if you try to bolt it on top afterwards, you're going to have, let's just put it nicely and say issues, right? They might not actually be security holes, but you're going to have a lot of trouble. And I totally agree with you, right? Security needs to be built in from day one. But he's also right that we have to have functionality. If this thing isn't sexy, if it's nice, it's not going to work. We're going to have problems with security, but we have to have a way to mitigate them later. So I'm not going to get into the how to do security. I'm just going to say and we have sessions on this here at the Open IoT Summit. I have a couple of colleagues, one of them is sitting right here, working on security and figuring out how to do these things. But yes, we need it. So how do we program these things? And I just selected 4 areas here that I'm going to try and approach, and there are probably more. So we need to have an operating system. We need to have the ability to talk to the devices that are electrically connected to my board. We need to have somehow a way to manage this device. And there comes in security. I need to be able to upgrade the device. I need to be able to reboot it. I need to be able to turn Wi-Fi on and off, right? I need to have the communication frameworks. That is, how do I actually talk to other devices over a network? And I need to have a way to do this easily. Not just all of the above that we need to do. We need to somehow make it easy to develop.
So are these your requirements? Is that what you said?
So are these my requirements? I'm going to say, these are not really the requirements. These are just buckets of things I'm looking at. Right? I'm going to divide more or less. So for example, when I'm talking about operating systems, the Zephyr project, right? You can get this nice, they did actually a nice job with the pamphlet you can get at the Zephyr booth. Zephyr is a solution we got started with the Linux Foundation, an open source, small OS. It is kind of real-time OS, but also the more important fact is that it is a small OS for developing for small, very constrained devices. So Zephyr in nanokernel mode, which is basically just a scheduler, requires 256 bytes of overhead. It's meant to run on, put yourself back 20 years ago and you were trying to figure out on how to free 100 more K of RAM on DOS. That would be a lot of memory for Zephyr. So we need a small OS for microcontrollers that are going to be everywhere. This is going to be the volume of IoT. This is going to be your humidity sensors, your light sensors, your, every kind of sensor that you want to put in there and forget about it for a year or two is going to be running on something like this. Now, why did we start a new project? And I encourage you to go to the Zephyr sessions that are happening here at Open IoT Summit and talk to the booth people. But the point was that it needs to be open source and it needs to be professionally developed. There are many other solutions. There are many other operating systems that, yes, you can use them. We just felt that each one had its own problems sometimes and very often because of how they were developed, they weren't completely solving the problem. So we decided to go for our own. It's actually not a new code base. It's been in production, it exists, and it's proven. So why am I talking about this? Because Zephyr has an API. Don't worry if you can't read it. My point is, there is an API to, for example, read from GPIO. But it's fairly low level. You're going to define all the values yourself. So you can do it. And if constrained devices, if you have to trade off time for space, if you need to take care of the space, this might be what you want to do. But suppose that this actually goes against what I said about ease of development. This is a trade-off. I'm trading off my ease of development for the most constraint, for the space that I'm available to use. So if I need to go one step further, just want to have an easier way of development, I might use the Solita project. So it's a higher level API for developing those devices. It sits on top of Zephyr, but also on top of Contiki, on top of Riot. It also runs on Linux. So you might develop your own device a higher level class of device. You might migrate from one to the other as you go by. You might have a device, and then the next series, the next edition, next version of that device has more RAM, and you decided to run Linux on it. You can port your application to it. The idea here for Solita is to solve most of those problems that you might have on, that you might commonly have. For example, I/O, right? So instead of having to define each one of my devices and each one of my GPIOs and SPI and I2C, the tooling will do that for me. Plus, it will integrate with comms. I'll get back to comms later, but you need to be able to communicate. It will do that for you, and also has hooks for persistent storage, device management, upgrades, rebooting, self-checking. And the API becomes simpler, right? So it has, like I said, a co-op API, which, again, it's still C code, but goes a little higher. But not only that, it actually has JavaScript and Flow programming. So sitting on top of that, and sitting on top of the C API, I'm now making available a way to do development in a way that is more simple. Why? Why do I want to have JavaScript at this level? Turns out that it's actually very nice to be able to write a device and get it to boot and log onto the network and provide a service with 50 to 100 lines of JavaScript, right? Just think of it. I've got this 100, 200 kilobyte of RAM device, and all of a sudden I can actually program it with 50 lines of JavaScript. Hell, even I might actually do this kind of device development. I'm more of a user space developer on Linux, but this might be something I can do. Now, I don't expect my mom to do it, but this is something that certainly enables a lot more people to develop, and goes to the vision of how and what the API should be. I'll get back to Flow in a second. Don't worry about it. I'm not requiring you guys to program with Flow. And I mentioned I need to have access to my GPIOs, to my sensors, to my actuators. The way we've been doing this at Intel has been the MRA project, libmra, you can download it from there, which is an I/O library. Now, I'm talking about Linux, but it's an I/O library that allows me to abstract how to read from each sensor, and where each sensor is, which I/O port it is. Is it on SPI, or is it on GPIO, and which one is it? But see, it also has bindings for Python now, besides JavaScript. So you see that we're going up on the stack and making it sometimes and every time easier to write applications. Now, I can't go and talk about JavaScript without bringing the big guns, right? We have Node.js. And it's amazing how this which as a programmer I would say, why are you doing this in JavaScript? But how amazing how this enabled the creation of an ecosystem of people, an ecosystem of modules that all of a sudden are available for people to use. So we need to embrace JavaScript development. We need to embrace a full JavaScript application without any line of C code that I have to write. I need to embrace the model of I need to just download my pieces that I want, and as long as left pad doesn't go away again, right, my application will work. So the incredible wealth of modules cannot be understated. We are doing this. We're providing APIs on Node.js. On top of Node.js, we can do a lot of things. So we can use the engine to do a lot of things. And another example of what we're doing at Intel is called the services orchestration layer, which is, again, based on top of Node.js using the Node-RED engine for bringing flow. So it allows me to have now a nice visual editor to develop an application. I'm basically dragging boxes. Again, this makes it a lot easier for me to develop. I'm not sure my mom would be developing that, my dad, who is an engineer, but isn't doing this, might. I mentioned, I just need to go back again, lower on the stack, and talk about the IoT project. So communication protocols. We need to, for the devices to be able to communicate with each other. And this is our solution for it. We need to have, on all levels of the stack, we need to be able to discover from the edge device to your more beefy controller, from your controller to your gateway, from your gateway maybe to the cloud. We need to have services on top of this. We need to define what a light bulb is, what a temperature sensor is, what a humidity sensor is. And when we go to different environments, I need to be able to understand the semantics of the data that I'm getting. So the Open Connectivity Foundation is creating those data models that I can use. And again, let's talk about bindings. We have the C core and C++ higher layer, but we do have, again, and you see this again and again, JavaScript. So let me just now basically summarize here what our vision is. And I'm going to spend some time on this slide. We need to have the small devices do something, right? So the things are basically these small devices at the edge that are probably going to run Zephyr. Some of them might be, very hard-coded, this one thing. I don't need any abstraction. I only have 8 kilobytes of RAM, but I'm going to run for 10 years on my cell battery. Some of them, you have a little more wiggle room. You run with Solita, which allows you to do more things. Which allows you to start, migrating upwards and downwards. It allows you to have different communication protocols. So instead of sending a simple BLE beacon, now you're talking the OCF protocol. Bigger devices would be running, Linux. It might be running Solita, might be running SOL. And here I need to stop and do actually a criticism to our own people. So yes, I'm going to criticize Intel in public. The point is that we have 2 APIs in JavaScript and Node, and they're not the same. They need to be the same. I need to be able to migrate upwards and downwards as I go. My new device might be different from the other. Yes?
What is SOL?
Services orchestration layer. It was on previous slide, yes. And it's interesting that they start with the same 3 letters. So when I was in a meeting, and this often happens in big companies, you find out there's another project that somebody else has been working on that does something very similar to what you're working on. Unfortunately, in our case, they complement very well. They just don't have the same API. So this is something we need to go back and fix. It needs to be the same API in JavaScript, the same API in Flow. So I'm developing here on a device using the JavaScript binding for Solita. And I migrate for a bigger device running Linux, which might be running the service orchestration layer, the same JavaScript API, if I'm using Node.js, for example. If I'm using Flow, I need to be able to move from one to the other. Another thing, in talking about commercialization, I need to be able to get services from the cloud. And I talked about before how giving my data comes with a service. I will give you my data, or some of my data, because now I control it, right? My device locally controls the data. I can select how much I'm going to give it to you instead of giving everything willy-nilly. But these devices, which are slightly bigger, might be able to actually have an interface. So I can use my browser or an application to program them and do things that the devices I bought do not do by themselves. I mentioned before, imagine light bulb talking to my vacuum cleaner. Usually when I buy those Roomba, or I have a Brava, they don't talk to anybody else. They have a function. But I buy a thermostat, which is smart, right? So here's an interesting thing. The thermostats are smart enough to know when I'm home or not. Why can't it tell the other devices in the house I'm home or not? Now you can clean because nobody's going to be on the way. Think of a collar for my dog. If the collar would be able to tell where the dog is, so don't go with the robot there because it's going to scare the dog, or worse, the dog is going to bite the vacuum cleaner, right? Dogs. Cats would jump on it. That's different. Cats get a ride on the vacuum cleaner. Dogs would play with it. So by actually giving me the ability to program those devices after I bought them, to do things that the makers of those devices had not thought of, I'm actually enabling a lot more in this community. I'm enabling a lot more functionality, and this creates value. Let's set ourselves back 10 years ago. What were smartphones 10 years ago? There were blocky devices with keyboards that allowed me to send and receive emails. It wasn't until the iPhone, and that's the iPhone 2, that actually had an app store that I could download things. Then all of a sudden, the devices had an aftermarket. The devices became more than what they were the moment that I bought them. I want the same thing for IoT. I need to be able to download extra applications onto my gateways at home because they're going to be powerful enough. They're probably going to be running my TV and my internet connection, but also brokering all of this network I have at home. So by downloading more applications, I suddenly have a market for people to innovate. And we might have, like the App Store, of 1 billion applications, 1,000 are interesting. But I'm suddenly creating a market. What you were saying?
There was a question or maybe a concern. I mean, I love it from a technology perspective, but as you said, you make the assumption that the end user wants that complexity in his home. And you're right, for the iPhone or for a smartphone that really worked out, right? People are ready to accept it because of the extra functionality. I think it kind of remains to be seen. If I think of myself, I might have I have enough to do with my browser, my iPhone. I want my refrigerator just to bloody work, and I don't want any upgrades there. It could be that there is it could go this way or that way. It could well be that you just say, oh, don't bother me with another upgrade.
Yeah, so you're saying that, I'm just going to repeat for the video. You're saying that it might be that users don't want this complexity. I don't want to upgrade my fridge every time. I don't want to have to program these things. I agree with you on that. I do not want to have to worry about upgrading my devices. That's going to be a security issue. I'm going to tell you to my colleague over there, we're going to have to figure this out, how to do upgrades without interrupting the service and reliably, because we have security, and we can't just, brick the device because of it. I'm going to address the point of the complexity, right? I don't want to talk about upgrading the devices in the sense of flashing a new firmware. When I began this, when I proposed this session, actually, I was thinking, I actually want the end user, somebody in your home, to come and be able to program the device by connecting dots and a web interface. And I was talking to my colleague Greg Burns in the office one day, and I exposed this vision to him, and he said, you know what? Do you think your mom is going to want to do this? And this is exactly what you said. No, they're not. But they might want to download applications. My mom does download applications from the App Store, right? So the point is that if I know how easy it is to download something that integrates Roomba with lights, I'll do it. And it might be a simple JavaScript application which solves the problem of security because it's now sandboxed, and I can control what it does without suddenly sending data to the cloud. So this allows somebody to come and program now the device by adding extra functionality to it that wasn't there when I bought it. And I created a market for it. And maybe it's not somebody in each home, but most people have somebody in their family, which is usually us here, by the way, who comes and programs their things. You know, we used to be the ones who programmed the VCR. Now we're the ones who install software and install apps on phones. That might be us again.
This model will work for things like, forgive me if I say hobbies kind of thing, but if we're talking about IoT space like health control or maybe connected cars, which is, we're talking about real lives and real reliability. If we open this and make everyone, okay, I download an app and make the car close to my garage and then how are we going to control this kind of things? Because here we're talking about people's life. It's not only
So,
Roomba talking to
yeah,
the
repeating what you said, how are we going to make sure that, you know, this is good for smart homes, but is it good for,
even smart homes. I mean, forgive me, if I give you the tool to build an app that controls your furnace and your oven and something goes wrong because I'm just a hobby, I'm amateur. I didn't really go through the whole cycle of testing, verifications, quality control. I'll build an app and suddenly my home is on fire. Because it's just like
yeah. So,
you're giving people ways to shoot themselves in the food.
yeah, so again, let me rephrase. So yes, even on smart home, but more so in even in other segments, in smart car and medical and, you know, industry, we're giving people rope to hang themselves with, right? I'm going to say that whatever we do, that rope is going to exist. And, you know, there's damned if you do, damned if you don't, because we're creating now suddenly a framework that makes it easy for people to shoot themselves in the foot, and I'm changing my metaphor, right? Should we make it easy for people to develop applications? And, you know, I personally think that there's a lot we can do to make sure or prevent those dangerous conditions from happening. So we should explore how to make applications well-behaved and not, you know, leave the oven on for 10 hours so that we have a problem. Which means that I think we need to look into this API, we need to look into this market so that those APIs exist, they're safe, and people know how to use them, right? So the easier we make for people to make applications, the easier it is to make sure they don't run into problems. If we have to ask people to write C code applications to run on a kernel in kernel mode, which means any bad pointer would actually just break the device and make it stop working. By giving them higher level language, by giving them the proper tooling, they would be able to avoid those problems, and we can have a hypervisor, we can have the execution environment to make sure that those bad things don't happen. And we're going to have to do a lot of teaching. I mean, you can download bad applications from the Android App Store, right, the Google Play Store. You can download bad applications today, but the world isn't coming to an end, which means that there is a way for people to know this is a very high-ranked application. We put the stars on them. So there are a lot of things we can do to make sure that it doesn't just break the world. Like,
I'd like to make a point that you have to expect the manufacturers that have equipment, that build equipment that has the possibility of being causing problems.
I'm just using the mic.
You have to believe that manufacturers who build equipment has the potential for being dangerous in terms of its use will have some level of responsibility for not making that aspect of their device programmable. For example, the idea that you might have a stove that you could remotely turn on is very scary. And I can pretty much guarantee you that nobody who makes stoves will enable that feature. It's just too dangerous. Anybody who puts internet capabilities into a furnace and allows programmability through even if it had the ability to install some app, I don't know what the app might do in a furnace, but if they had that capability, they're not going to allow that furnace to be put into some mode where it turns on the gas but doesn't ignite it, for example.
Yeah, same thing
Right.
for a garage door, for example. It would have to have the security to be able to detect when an obstacle is there and not force it its way through.
But the thing is that actually you didn't discover those faults until later in the game. Like, for
Well-
example,
that,
All of us know about that.
the,
What happened to visitors?
I don't,
Open their cars that can bus and
I,
the car was hacked remotely.
yeah, but those are bugs. Those are bugs, though. But now,
But I would call that there's no anticipation for governments for the future. How are you
there,
going to build this?
there will be. I'm pretty sure there will be regulations in place. Right, there has to be, and just like there are regulations in place for existing appliances in terms of the safety requirements that they have to meet. So the fact that you make something connected does not change. In fact, it makes it more stringent in principle. But you know, that doesn't mean to say that this cannot be stopped. Right, IoT is happening, it cannot be stopped. There will be just some phenomenal use cases. And there will be some unfortunate situations, I'm sure, but they will largely be bugs.
But and
Not
here's the
intended.
thing as well. So just take the example of what you said about bugs. We need to be able to upgrade devices. So those bugs, when they're found, and there will be bugs and they will be found, can be patched. Right? We need to be able to do that. But take another example, which is right now what I have today, like the islands of everything. Everything is connected to the cloud, which means that they're vulnerable for remote attacks. But I want those devices, the smaller ones, the ones that are most vulnerable because they have more difficulty upgrading, to not talk to the world. They should be only talking locally, right? So that vision I'm showing you of making sure those devices are going through a beefier device that has more protection, that has more of an ability to react to problems and upgrade itself more often, that helps mitigate the issue. Right? So we need all of those. We need those small devices, and we need to be able to program them, and we need to be able to upgrade them, maybe not easily. I don't know how easy it is to upgrade a device with 8K of RAM. But we also need the bigger devices to shield them all. We need those firewalls. There's just no way around it. Any other questions? Yes, Bruce.
So, you were, in your talk, you talked about Soletta, and then you also mentioned Mirage, the two APIs look at sensor I/O. Going ahead the next 4 years, do you think it's better to give developers more options to do the same thing, or try and steer them down the route of one way of doing it?
So the question is, as an example, Imran and Solita, should we give them more options to do the same thing, or should we steer them towards a preferred solution? I like the diversity. I like having diversity to find the right solution. So we're in the stage right now where I cannot tell you which API on any of those things, despite my recommendations, is going to be the one that's going to survive. I need that diversity for applications and application developers and the framework developers to be able to figure out how to do things right. It's nice to have that competition, but eventually we need to converge to a solution.
That's my question. Do you want convergence?
I want convergence. It might not be today. I need that diversity today because we're too immature. So what I showed you here, this is for 2020. In 2020, I do want to have a converged solution, which might be that MRA got merged into Solita and then all of the functionality is available in it. Maybe that's the solution.
How about languages, say JavaScript and Flow? What's your
So again, on languages, on one hand, I do want to have the flexibility and not tell you which language to use, because you might be more familiar with Python than JavaScript. On the other, there's such a thing as, again, a convergence. In specific of languages, if we talk about dynamic languages, as long as you have a nice core of it, you can do bindings and just let you choose. So I would say that specifically for languages, it's better to allow people the opportunity to do things without, as we said before, allowing too much rope for you to hang yourself with. Anything else, because we're out of time? One quick question?
So one of the reasons I think currently why they have this cloud approach, or even if I just switch on something and go to the cloud, because this economically scalable, because I can have a remote software infrastructure which is basically rather than doing
So you're telling me that why people are doing cloud is because right now it's economically scalable. You're probably right, and this is not going to be the case once we have, billions of devices. You're right on that. I think there are more reasons for that, and we can talk more about why. But I think there are more reasons. So we're out of time. I'm here until Wednesday, so feel free to talk to me anytime. Thank you for coming.